System for defining and reproduction handball strategies in Second Life on demand for handball coaches education. Coaches play an important role in introducing people to sports and in helping players and athletes to improve and achieve success. Coach education programs aim to provide coaches with the competence for this job. The continuous need for education and the significant changes in European policies and regulations overseeing sports coaching and training require the adjustment of the teaching models and methods to the needs and potential of teachers, students, and technology. Our goal is to develop a new resource, a software system combining three-dimensional automated avatars in a Second Life virtual world, an external control server, and an helper desktop application. Aiming to improve the quality of educational content by allowing trainees and coaches to visualize tactics in three dimensions in a shared environment, where they can analyze them from the different perspectives and cooperate by demonstrating changes to the story tactics, using their own avatars alongside automated avatars players, as known as bots. System architecture. This is merely the overall data flow model, conceivably applicable to a wide range of virtual world platforms where the coach, trainer, creates and edits team tactics, the team movements, in a non-virtual world piece of software, the tactics application. Tactics application prototype. This is an overall look of the tactics application. It follows a common placeholder approach to represent the player position on the field, with a timeline to help define movements and actions. For instance, the trainer can start the process of creating a new tactic by selecting from a set of predefined initial player layouts, organized into defensive, offensive, or general groups. Using the timeline at the bottom of the application window, the trainer can specify the position of each player at each specific moment. The trainer positions the timeline at the desired moment and drags the players to their position at that time. Using buttons and options in the interface, the trainer can specify whether a player should execute the movement by walking or running, and whether displacement should be done together with some other motion, for instance, moving arms in a defense stance. Movements done without displacement can also be defined in a similar manner. While creating or editing a tactic, the trainer can employ the play, stop, or record button at the bottom of the screen to preview the tactic execution within this application. Whenever desired, the tactic can be saved as a file and placed in the folder structure of the web server, where the web service is running. Following a common software methodology of interactive and incremental development, several interface features have been developed and refined. Virtual world-based handball coach education system. We are developing a prototype implementation in the Second Life virtual world of the model presented previously. To test it, we built a handball field so that the team tactics can be understood in context, as seen. The trainees can use the seats on either side and use Second Life built-in camera control features to watch the team tactic from any desired perspective without having to position their own avatars. Trainees can, however, move their avatars onto the playing area in order to better demonstrate and understand a proposed movement to the other trainees or the trainer. For this purpose, the field was built on 1:1 scale. It can be visited at the Utopia Portugal 6 server in Second Life at the shown coordinates. It is provided to the trainer the option of requesting the creation of all automated players at the beginning of the virtual learning section. Then, from within a virtual world, the trainer will use a command system to issue the commands to, for example, request the execution and pause or unpause a stored tactic. Command system sends the command data to the learning platform, which then directly controls the execution of the tactics, that is, the movement of all automated players and the ball. The trainer can then request the destruction of the players, example, log them out, at the end of the session or whenever desired. This is currently done by clicking in Second Life terms touching two buttons on a virtual control panel as seen. Once the bots log on, the process has been completed. The handball field and system are prepared for a synchronous learning training session with all automated players ready to execute tactics. From this point on, the trainer can issue commands to the web service or e-learning platform as a private textual conversation with one of the automated players whom we call the master bots. In the current prototype, it is the goalkeeper. That is, by sending instant message through the internal Second Life instant message system. The trainer's command system is therefore a combination of the visual elements, the buttons, and the textual commands that the trainer issues to the master bot. The tactics execution process takes place in the following manner. When the trainer issues the command to execute a stored tactic, the master bot receives the trainer's instant message, and that event is detected by the web service controlling the bots, which process the instant messages, loads the appropriate tactics definition file, and initiates its execution by commanding the action of each player and ball. During this process, the trainer can send an instant message command to the master bot requesting that movement pauses or unpauses as the educational situation progresses. Further work. Here we presented the software architecture of the system and the current state of the prototype under development, as well as the technical approach and details used in its development. It is expected to improve the reproduction of movement and tactics by incorporating in the animation process Second Life avatar gestures to better express the fine elements of the tactic. Recently, it was established a protocol with Movement Laboratory of Lusófona University to use motion capture to integrate them in the automated avatars. This way, we hope to obtain the most reliable techniques used in team handball movements. The ball movement itself is still under study. While different worlds may require different solutions, for Second Life we are experimenting with a combination of a ball-shaped automated avatar and ball-shaped virtual world objects that can be attached to the hands of automated players and thus follow their motions accurately. Although this work is focused on team handball, we believe the overall structure can be used as a starting point for developing systems for coaching education on other individual and group sports and physical activities in general.